Good morning. Today we're going to talk about Chapter 9. So if you have your new packet, you can follow in the packet. We're going to be doing pages 234 to 236. And basically what we're doing here is conic sections, which they're called conic sections because they are sections of cones. Okay, in the past or in geometry, you probably thought of a cone like an ice cream cone, something that looked like this. Okay, had a base, had these slant height, but just kind of like started at a point and ended down at a circle. Okay, but the mathematical definition of a cone is actually something more like a plane. Okay, it looks like one of these. It's a cone that has this vertex here, and it not only goes down, but it also goes up. And it doesn't end here, it goes on forever in both directions, kind of like a plane does. And if you were to take a section of a cone, and what I mean by a section, a cross section, so you take a plane and you were to slice the cone, what happens is you can get different conic sections. Okay, so if I were to take a plane and slice this basically horizontally, this cone and this plane would intersect at a circle. Okay, if I were to slightly slant that cone, let's see. Oh, I see. This one actually is showing an ellipse. So this one down here, it's hard to see that on your packet. But this is if you take a plane and it's kind of at a slant, okay, and you sliced it that way. This thing would be your ellipse. So the ellipse, it's not going to be exactly circular. It's going to be kind of an elongated circle or an ellipse, okay? This one up here shows the circle, where you've got a horizontal cross section. This one up here shows a parabola. You can see this cross section here. Okay, so if you take a plane and you were to slice it with a plane that's parallel to this edge, you get something that kind of looks like, okay, it's kind of tough to see, but this plane intersecting with the cone, and you'd get this parabola there. Okay, and then this one, if you have a vertical plane that goes through the top part and the bottom part, it almost looks like two parabolas, but what we'll see is that it's not two parabolas at all. It's a completely different conic section with completely different curvature, completely different formulas, okay? So, and actually I'm going to show you another picture. If you don't like my pictures, here's another visual. You can find something like this on the internet. If you slice it horizontally, you get a circle. On a slant, you get an ellipse. More of a slant where you're actually parallel to this edge. Okay, so you're never going to get the other side of that thing. So it's not going to be an ellipse. It just opens up and never closes. That's a parabola. And this one is a vertical cross section. Okay, there's another one here that shows the actual planes. So a horizontal plane with the cone, circle, and a slant, you get an ellipse. There you get your parabola and your hyperbola. Oops. Okay, so let's go to the next page. We're going to talk about how we represent these algebraically. Okay, so when you represent, these will all be quadratic. I want to say quadratic equations or quadratic functions, but they're not necessarily functions. As you can see, a circle or an ellipse is not a function. Okay, for every x, there's not, or you could just say it wouldn't pass the vertical line test. Okay, so, but all of these generally can be written in this standard form right here. So ax squared plus bxy plus cy squared plus dx plus ey plus f equal to 0. Now that's usually not the best form in order to actually analyze one of these. So we put them into standard forms for each conic section. Okay, a, b, c, d, e, and f are stand for constants. Equals sign could be an equality sign if you want the region inside the circle or outside the circle. Okay. And at least one of these is not equal to 0. Okay? Now, a definition, a circle The geometric definition of a circle is the set of all points in a plane, and that's important, in a plane, okay, each of which is a fixed distance from a fixed point called the center. That fixed point is called the center, and that fixed distance we call the radius. Okay. So the proof and the origin of the equation of a circle. Okay, let's look at this. Oops. So I could draw this right here. I could draw my center. My center, I'm going to call it H comma K. That's my fixed point, the center, HK. Find the center, your fixed point, H comma K, and the radius. The radius is going to be the distance to any point on a circle. So I can pick any point on this circle and call it XY, where X comma Y can be any ordered pair that actually lies a fixed distance away from the center. I'm going to call this fixed distance R. Okay. So I can use the distance formula to find the distance between these 2 points. So the radius is my distance, is equal to the square root of x1 minus x2, so x minus h quantity squared, plus y2 minus y1 squared, so y minus k quantity squared. That's just your distance formula. Squaring both sides, you're going to get r squared equal to, and the square root goes away, so x minus h quantity squared plus y minus k quantity squared. And there is your formula for the equation of a circle, where r is the radius and h comma k is your center. Okay. So now that we know that, we can look at these. And these are already in standard form for a circle. Okay. And you can see here, x minus h squared plus y minus k squared equals your radius squared. So your hk, your center, is going to be 3, negative 2. Your radius is going to be 5. Here, this is like x minus 0 squared. So your x coordinate of your center is 0. Your y coordinate is 4. And your radius is the square root of this thing, because that's r squared. So your radius is 12. And here your center is negative, because it's always x minus h. So that's like x minus a negative. We're at 7. Your y value is positive 1.1. And this is your radius squared. So this is kind of a weird one. So your radius is going to be the square root of the square root of 13. So r squared equals rad 13. If I want to find r, it's going to be square root of the square root of 13, which we could call 13 to the 1/2 raised to the 1/2, so 13 to the 1/4, or the 4th root of 13. Okay? So whatever, if you're in standard form, this thing is always your radius squared. Okay, let's go to the next page and we'll do a few on the graphs. Okay? So this, okay, now this, what we have here is in, it's not your standard form for a circle, okay? But it's kind of standard form for a quadratic relation. So it's in this form that we saw at the top over here. So what we want to do is put it into this form, okay? Your standard form for a circle. So what we're going to have to do is complete the square twice. Let's put the x's together. X squared plus 2x. Put a space there to complete the square. Then put our y's together. Plus y squared minus 4y plus blank equal to, and I'll move the 11 to the other side, becomes positive. Okay, so here I take, complete the square, I take half of this and square it. So 1 squared is 1, which means I'm going to add 1 to the other side. Here I take half of that, which is negative 2, square it. I'm adding 4. Add 4 to the left side. I have to add 4 to the right side. So this is x plus 1 quantity squared plus y minus 2 quantity squared equal to 16. And you can see your center. It's going to be negative 1 comma 2, and your radius is equal to 4. Okay, so negative 1 comma 2, there's your center. Your radius is 4, so I'm going to go up 4. I'm going to go down 4. I'm going to go right 4. 1, 2, 3, 4. It might be good to get in the habit of labeling these points. That's going to be 3 comma 2. This point was negative 1 comma 2. This point's negative 1 comma, we're at 3. We went up 4, so 7. If I go left, 1, 2, 3, 4. So at negative 1, I go left, so I'm at negative 5 comma 2. And this point would be negative 1 comma negative 2. You can draw your circle. Okay. Let's do the next one. We'll just practice one more of those. So x squared minus 10x plus something, and then plus y squared minus 6y plus something is less than, I'm going to move the 30 over to the other side, so subtract 30 from both sides, I get negative 30. Completing the square here, half of that is negative 5 squared is 25, so I'm going to add 25 to the other side. Half of that is negative 3 squared, add 9. So this becomes x minus 5 squared plus y minus 3 squared is less than, adding those together, I'm going to get negative 5 plus 4, negative 5 plus 9, so 4. Okay, so my center is at 5 comma 3, and my radius is 2. And I want everything where these values are less than 4, so that's going to be inside your circle. Okay, so 5 comma 3, 1, 2, 3, 4, 5, 1, 2, 3. 5 comma 3, and then the radius is 2, so if I go right 2, 1, 2, that adds 2 to your x coordinate, 7 comma 3. Left 2, 1, 2, that subtracts 2 from your x coordinate, so 3 comma 3. And up 2, I'm going to add 2 to my y, so 1, 2. That's going to be 5 comma 5. And down 2, I'm going to subtract 2 from my y, so that's 5 comma 1. There's your circle. Okay, notice it's less than 0, not less than or equal. So this is actually going to be a dotted circle because the points on the circle do not satisfy the inequality. They have to be less than, not less than or equal to. And then I can shade in the inside. Okay, so it's a dotted circle and we're shading in the inside. Okay, then down here we've got 2 problems here. Center, so that's your h comma k, and then a point here. Okay, so we don't know the radius. You might want to graph it. Sometimes it's helpful to graph these, sometimes you don't need to. Center is 2, negative 3. I'll graph it. 1, 2, 1, 2, 3. And then you've got the point 5 comma 1. 1, 2, 3, 4, 5. Up 1. 5 comma 1. Here's my center, 2 comma negative 3. If I want to find the distance between these 2 points, that's going to be my radius. So the radius is equal to the square root of 5 minus 2 squared plus 1 minus negative 3 squared. Okay, so the square root of 3 squared, which is 9, plus 1 minus a negative 3 gives you 4. 4 squared is 16. So your radius is equal to rad 25 or 5. Okay, so now we have enough to come up with our equation of our circle. And remember, it's x minus h. Our h value is 2, so x minus 2 squared plus y minus k. Y minus a negative 3, so y plus 3 squared is equal to your radius squared. The radius is 5, so the radius squared is 25. Okay. If you wanted to continue drawing the circle, our radius here is 5, so this should be fairly easy to draw. We usually will go from there. I'm going to go up 5, gets you to 2, down 5, down 5. I can't label that point. The x coordinate is still 2, but my y coordinate is down 5 from -3, so -8. I go right 5, 1, 2, 3, 4, 5. So my x is going to be 2 plus 5, 7, -3. I go left 5. So I'm going to be at -3, comma, -3. And there's your circle. Oh, I'm drawing my circle right over my answer. That's okay. Okay. You're not required to draw this here, but I just drew it because sometimes that helps you visualize. Okay. Center 4, 1. And a point. Okay. So let's just find the distance between these two. So the distance between these two is going to be the radius, the square root of, let's do 4 minus -3 plus 1 minus -2. So the radius equals, that's going to be 7 squared. 1 minus -2, that's 3 squared, so 9 squared. 3 squared is 9. So the radius equals rad 58. That does not simplify. So the center here, that's your h, that's your k. So x minus 4 squared plus y minus 1 squared equals your radius squared. So that's going to be a regular 58. Okay. And that's all for today. Thank you all for watching. And I will see you soon.